Okay, so far we've seen two strategies for going through all of the items that are on this list of things. So we've got a list of all the Canucks players. We've said we can write a for each that says I want to go through all of the people on the list and do something with them, which in this case is print them out. And we also gave you a sample of a counted loop where you do things by position, which I think happens to be in the other portion of code. Yeah. So there's the counted loop idea that we looked at for I equals 0, I is less than maximum number, I plus plus. Go get me the thing at that particular position on the list. So two different strategies. Do you want them by number, refer to them by number, or do you just want to go through all of them and have that thing change? Okay. We said we tend to prefer this one because it gives you all of them and you don't have to worry about, did I get the first one, did I get the last one, does I start at 0, does I start at 1, all of that sort of goofiness goes away. There's sort of a middle ground between a counted loop and this one, okay? And it's also it's sort of the strategy that you would use probably if you were retrieving things in real life. And it's maybe a little bit more wordy than the for each, but it's in some senses also a little bit more understandable. So suppose that there's a pile of stuff sitting on the floor over there, and in the normal counting loop, what would happen is I would go and I would say, oh, go get me I'll go grab the number 0 thing from the pile, I'll go grab the number 1 thing from the pile. I would have to keep track of the numbering system for the things as I'm getting them out of the pile, right? Let me give you another option. What I'm going to do, because I'm too lazy to worry about numbers, is I'm going to get somebody else to worry about numbers. Okay? So I'm going to give the job to this guy here, and I'm going to say, your job is to be able to go get things from the pile for me. Okay? So I put somebody between me and the pile. Okay? And now what I'm going to do is I'm going to boil my life down to just 2 questions for that person. I'm going to turn to him and I'm going to say, is there something else in the pile? Not even going to look. If he says, yeah, there's something else in the pile, I say to him, oh, could you go get that one for me then? He brings it back. There it is. Anything else in the pile? Oh, yeah, okay, go get that one for me. He brings it back. Just 2 questions, either something in the pile or go get it for me. Okay? Eventually, at some point, I ask him, I say, is there anything else in the pile? He says, nope, nothing left. And I go, okay, I'm done. Gone through that pile. Notice the advantage of that system is I didn't care about the numbers. I wasn't at all interested. I just got 2 questions I have to ask them. Okay? Seen that strategy before? The sort of the analogy is, think doctor's office. You know, and doctor's office has got all these chairs lined up, and the chairs are numbered 0, 1, 2, 3, 4, 1, 2, 3, 4, whatever. They put up a sign that says, now serving whatever, right, for which chair is supposed to go into the doctor's office next. If the doctor's too cheap for a secretary, he's just starting his practice, he goes into the office first thing in the morning, there's people sitting in the chairs, he looks up at the number on the wall and goes, oh, number 1. He says, oh, let me go get number 1 out of the chairs, and now let me remember to flick the sign to say number 2 for when I come back later. Deals with the number 1 patient, comes back out, looks at the now serving number. There's that idea of the doctor's in charge of the numbers. What does the doctor do when he gets a little bit more money?
Hires a secretary.
Hires a secretary. So now he comes into the office in the morning. Doctors really don't like to talk to people anyway, right? Regular patients. So now the doctor does what instead of looking at the chairs? Walks up to the secretary and says, hey, is there anybody in the office I have to deal with? Secretary says, yeah, there is. He says, well, could you just send them in then? Or go get them for me? What does the secretary do?
Finds out what's
How does the secretary find them? Checks the number, goes, oh, now serving. And so all that the doctor's really done by employing the secretary is get the secretary to take care of remembering the number and bumping the number. The numbering system is still there, but the doctor's isolated himself from the numbering system and doesn't care anymore. Just get to ask those 2 questions. Okay? So there's the philosophy in why you do that. Notice that the big advantage there is I still don't have to ask about, you know, is the first one numbered 0 or 1? Did I get the last one when the now serving says this and there's nobody there and all of that sort of silliness? I don't care. All of the details in my life are just 2 questions. Okay? So is there a name for that in English other than secretary? Best one I can think of is on construction sites, they're called a gopher, right? It's somebody that you get to go for some stuff, right? And they're just always on call, and whenever somebody needs anything, they say, oh, go get me this thing, and it just magically comes back. And they never care where they have to go or how they have to do it. It's just like, I want this thing, go get it. Okay? So we're sort of playing the same rule. Maybe what I'll do is I'll use the word secretary to talk about it, because that's the analogy we've been using. So, in the case of that thing, what I need to do is I need to basically find a way of connecting the secretary to the pile of stuff. Okay? So in our case, for hockey players, the pile of stuff is the Canucks. And so what I'm going to do is I'm going to ask the array list, whoever's in charge of all this stuff, to go hire me a secretary. Okay? And so the hiring mechanism is to use this word called Iterator. And in case you don't know your Latin, an iter is a road, and so an iterator is to walk down the road. So see the things that are available on the road. Okay?
That's fine, because doesn't iteration mean to do something repeatedly?
Well, no, actually that's a bad thing about the word iterate in the English language, is that iterate means to go through it once. Reiterate actually means to go through it for the second time, but the common usage has been to make reiterate and iterate mean the same thing.
Right.
But yeah, the same word, iterate, as in reiterate, go through it again, only actually really just for the first time. Okay, so that's where that word comes from. And think of that as just go get me a secretary who's going to be in charge of stuff that's in that pile of Canucks. So I'll use the word secretary there just to give you the sense of who I'm going to talk to. And now we get to decide what the word is here. Well, the unfortunate part about the word that they chose for Java is that it's going to look like this. If I spell hockey player correctly. And by default, the import isn't there. Be careful here, it's always Java util for most of our stuff. So that just lets it know about the iterator. Okay? So the secretary is the person who's going to go grab the stuff from the Canucks pile of hockey players. And this is the talking to the Canucks team and saying, or the bunch of Canucks, and say, go hire this secretary to do this job for me. Okay? So I got the secretary from the pile of stuff. She knows now where the stuff is. So now, from now on, what I do is I say, while secretary dot has next, as in ask the secretary, do you have another one? If the secretary says, yes, I do, then I say, well, hey, secretary, go get me that one. And since I'm asking her to bring something back, I'm going to hold on to that in a hockey player variable like that. And now that I've got that person, I can do whatever I want with them. In this case, I'm just going to print them out in the doctor's office. That would be go treat them or do whatever, and then go back and go grab another one. So as much work as you want to do there. Print out their first name, for instance. And just let me put a print statement on there so we can see this in the output. And we'll run this thing, And in the Iterator version, try run again. In the Iterator version, it still prints out the first names of the people that are on the list. Okay. So, why would you use this one over the for each? There's a couple of advantages. The first one is that the for each just runs and there's nothing you can do about it. And it runs from start to finish and it goes through all of the stuff regardless. Okay? The advantage of this Iterator version is that I could go, for instance, pick out the first one before I started the loop, because sometimes getting the first one is important, and then use the Iterator to go through all of the rest. Okay? Ask the Iterator to grab the first one so I can do something special with it. Go through all of the rest would be a fairly typical pattern of why you'd want to use it. So if you need a little more sort of granularity on being able to retrieve things, you can do them that way. So every time you call secretary.next, you get the next one. You don't even have to use it in a loop. You could call secretary.next to get the first one, secretary.next to get the second one, and secretary.next to get the third one, and put them in 3 separate variables if you wanted. Okay, if you wanted it outside of the loop. So for unit testing things, this is going to become a handy way sometimes to be able to test. Now,
are you going to go through that? Because I'm kind of curious how you would get the Iterator to start at position 2.
Just throw away the first 2. Ask them to get them and throw them away if you wanted the number 2 item. But don't worry about that for now. We're just looking at the big picture of how do you do, it's still really how do you do all of them in this case. And so again, I'm more interested in how you do all of them than how do I do a specific one. Okay, so they're just really a different pattern. A couple of things that are weird about iterators. The first thing that's weird is that word, because I mean, technically speaking, if we're using our rule, that should be called get iterator, because that's what it does. It goes and it fetches a thing for you. So it should really be called get iterator. And the difference between these two words is that the small I iterator is the words, go get me one, and this is the thing that it gives you back. That's their job description. And basically this word says the only 2 things that that secretary knows how to do are the 2 questions that we've just used. So gophers are really dumb. They're not hired for their intelligence. You only ever get, when you hire them, expect them to be able to answer 2 questions for you. Do you have another one? And oh, if so, go get me the next one. That's all they know how to do. That's their entire lives. Okay, and so that's just basically their job description that says the promise is that secretary will be able to answer those 2 questions. And they will only give you back hockey players and nothing else, because that's what should be on the list. Okay. The other thing that's weird is that use of the word next, which is another just awful, awful word in English. Because if I say today, I'll see you next Friday, does that mean tomorrow, or does that mean the following week? Right? It's sort of ambiguous. Most people would probably say it means the following week, but in fact it means go get me the one that's in the pile next. I don't even know if I can say it any other way. Okay, whichever one is going to come up. So it means, you know, not the one 2 down, but the one right away. And so maybe a better terminology would have been get current, which even then doesn't quite give the sense of it, right? There's almost no good word that describes it, but the next one is the one that I'm about to choose that I haven't done yet. Okay? Silly, silly word there. And has next only makes life more difficult, right? Because now there's that word next repeated. The good news is that this little pattern repeats over and over and over again. If you're going to use it, all that you do is it becomes, you know, a list of cats, and so then you get it, you talk to whoever owns the cats and you say, go hire me an iterator who will go through cats for me. That word becomes cats, and then this word here becomes cats, and then you do whatever you want to do with your cat at that point. Okay? So the pattern really never changes from this thing other than that some of the words change. And so after a while, you just get used to writing the pattern, or you copy and paste it and change the words, and off you go. Okay? Now, here's the really interesting thing about the evolution of Java. In actual fact, this version came before the for each. Okay, so we'll say in version 5 of Java they had this, and people started using it, and there was no for each. And the reason they made it was because you didn't have to worry about first and last and all those things in that little pattern. It's still, the pattern would give you all of them regardless. Okay? So they started out with this one. Well, guess what? After people had used it for a while, they started to complain, this is an awful lot of typing. I'm always typing exactly the same thing. And so what they did in version 6 or whatever it was of Java is they turned around and they said, well, we'll make a shortcut for you. When you type this, we'll have the compiler write that for you. Okay? And so they're actually equivalent. This is really just less typing. The compiler just splats in the code that you see down below in the case, and you never actually see it. You'll never see it in the debugger. You'll never see it anywhere, but that's what it's doing. And the bottom line of that is that the only way you can use this pattern or this pattern for going through all things is if wherever you're getting the things from, in this case array list, will hire the person that's necessary for you to do this. If they won't give you back the gopher that will do the work for you, then if they don't provide that facility, then there's no way that you can use either of those two loop strategies. Okay? So the bottom line in Java is that if you're planning on going through all of the things that are in that somebody's holding on to, you can either use size and get, how many items are there, or retrieve by position for however many items we had, the counted loop, or if they offer this facility, then you can use that loop. And sometimes people who hold on to things will offer you can only get them by position. Sometimes they'll say you can only get them by me supplying you a gopher to go fetch them for you. And sometimes they will give you the combination of either or. If they're nice, you can do it this way or you can do it that way. Okay? And array list happens to allow both, because you can say go fetch this person or go hire this person, or you can use the counted version with get. Okay, so we now have 3 different loop strategies. So the recommended order is try to get away with this one first because it's the simplest and most convenient, easiest to type, most error-free. If you can't use that one, then this strategy is better because although it's more long-winded, you still don't have to worry about getting the first and the last, and there are some ways that you can use it to start and stop the loop rather than always having to go through all of them. And finally, if you can't do it that way, then go back to the old counted loop as the last strategy because it's the one that's most error-prone. Okay? And so we're going to need this because we're about to do something with this class later on with these hockey players we're going to need that facility of being able to talk to this thing and ask for it. Okay. Questions about that style of loop? It's the most natural of all the styles because it's the way that people tend to use things. Oh, got any more? Yeah, go get it. Got any more? Go get it. Right? That's all there is to it. Typically done with a while loop because you don't know how many you're going to get. You just keep asking until they stop. By the way, there's a key thing about the difference between when you should use while loops and when you should use for loops. You use for loops when you know how many things you're going to go through, pretty much exactly. And whenever you're uncertain about how many things you're going to have to go through, you use a while loop. So while loops almost always have a sense of Nobody's telling me how many there are. I don't know how many times I'm going to do this, so I'm just going to keep going. Okay, we did some stuff with a hockey driver. We tested it out. We made sure that we knew how to use some loops. We've got equals and compare to built in this thing. Now it's time to take the next step up in the game. In our driver, when we searched for somebody, wherever we did index of, if I can even find it, the search for always involved, let's make a sample, let's go see if we can search the list to find them. There should be an if statement in here to say, did we find them or not? And in this case, we assumed we found them, so now we can update them. Okay? So there's this piece of code that's going to repeat over and over again every time we want to find somebody. Okay? That's one thing. And the other thing that's going to happen is at some point somebody's going to come along and they're going to want to keep some extra information. So I might want to say team name is Canucks, for instance. Okay, so now I've got some extra piece of information that I'm going to keep so I can print out for my headings. I can say, oh, okay, this pile of players here really refers to the Canucks. Maybe I get some extra information. What else can we put in here? Team address is, you know, whatever it is, West Georgia or whatever it happens to be. Okay. And so I'm adding in a whole bunch of extra information about things that I need to keep track of for the team. Okay? What do you do in Java when you start to have this variable, and the Canucks variable all needing to work together? Back to day one. What do you do when you have three variables that all somehow belong together? You make a new class. Because the first goal of a class is to say all these variables belong together, they need to be manipulated together. And so we're really saying here that those two strings and that Canucks array list somehow belong together as one group because they're all serving one particular function. Keep track of all the stuff about the team, its name, the players on it, etc. Okay? So the next step of the game is to say, instead of doing all this work ourselves and instead of making this mess of things, we're going to go now turn around and write a team class. Now what information do you want to record about the hockey team? Let's go back and see what information we were recording already when in our driver. We said, well, okay, we were recording the team name. I'll put that inside team. And I'm just going to not worry about what specific one it is. What else were we keeping track of for the team? Address, yeah, too difficult. Anything else?
Division.
The what?
Division.
No, just from the driver that we've got.
Players on it.
We're keeping a list of all of the players on the team. So way back when we started out with this thing, this list of all of the Canucks. So I guess the list and the name of the team at the very least belong together. And we'll have to add our little bulb here at some point to get it to recognize list problem. Oh, got it already. We're okay. So I guess now if we're grouping those two things together, we should do a constructor for team. What information do we need to initialize in team? The name needs to be passed in. What about the roster? if I form a team, how does it start? With no players on it, right? So if you think of this as being my fantasy hockey team, eventually your fantasy hockey team starts out with nobody, and then you eventually add players to it as you choose your players. Okay? And so I'm going to change this word here, make it more general, and say it's not just Canucks, but this could refer to any team's roster or group of players that I'm collecting. So team name needs to be initialized to whatever in-team name was. And roster needs to start out with a new array list that's empty, that can only hold hockey players. And now we'll add our bulb for array list, add the import statement, and there's the constructor. Now, that information is really the same information that was in the driver. So I just took the list here and I dropped it into the team, and then I said, oh, okay, the constructor then is going to make that thing, so I'll take that portion of it and stuff it into the constructor in the other class to do the initialization. So this is just a recognition, oh, instead of having all these variables floating around free, let me tie those variables together in one class. Okay, so now if we were going to use our team, let me just start a brand new driver so that I don't have to look at hockey driver so much. I'm going to call this one team driver. And this one I'm going to include a main, start out fresh. Get rid of hockey driver so I don't have to look at it. Now what we would do if we were forming one team is we would say my team is new team of, now I'm going to have the Canucks as my team name, or Daryl's team, or whatever it happened to be. Okay? And so when I call new team, we're going to go into the team object, and the team object is going to do what constructors always do. It's going to copy the name Canucks into that field, and it's going to make sure that we've got an empty array that's available for holding on to however many players get added to our team. Okay? So basically what I've done is I've hidden the list and the team name inside of another class. The fact that I've marked them as private means that people can no longer get at them. It's now this team class that's in charge of manipulating them. Okay? So you can no longer touch those variables. In the team driver, you can't get at those variables anymore. You can only ever ask the my team object to do the work for you. So, pick your first player. So we'll pick a goal scorer. Can't remember which of them scores more goals. So there's the new hockey, here's the hockey player I want added to my team. I guess I'm going to have to somehow add them to the team. And the thing that I'm going to talk to get them added is my team. So I'm just making the hockey player variable directly here. Instead of making a hockey player and then putting the variable in, same difference. So I'm saying, I want Daniel Sedin on my team. Hey, team thing, please add him in and keep track of them. And it's complaining because we haven't written add yet for team. So we'll go into the team class and we'll say public void add. And what do you give it as an argument? Some hockey player. What do you do when somebody gives you this hockey player to add to the team?
Put it in the roster list.
Let the roster take care of it. So talk to whoever's in charge of the roster, the guy who's managing the list, and say, oh, you go ahead and take care of them. So in the driver now, suppose I was curious and I wanted to find out how many people I'd got on my team to see whether I'd reached the limit of the people who were allowed. I would say my team dot size, tell me how many people are there. Then I would say int current team size is, go talk to the team, person who's in charge of the team, tell me how many people you've got. Same deal there. In the team class, I guess it has to respond to the word size. If you ask the guy who's for the team class, how many people have you got on your roster, what does he do? He could count them, or maybe he's got somebody who's smart enough to ask. Who's keeping track of all these things? The roster is. So we could go to the roster and we could say, you tell me how many people you've got. And we'll get whatever number we get from the list that's in charge of keeping account of those things. And then all that we have to do for work is we'll just send back that number. Okay? So let me give you the workplace analogy. Originally, in our original driver, I was the guy who was in charge of managing the team. It was a one-person company, and whenever I hired somebody or as a hockey player, I had to keep track of them, put them on my list, and I was keeping track of the list. I got tired of keeping track of the list because there was too much work with doing all the things that it did to put the paper on and worry about those things. And so instead what I did is I came along and I hired a team manager, and I said, you can be in charge of the list. And so now whenever a hockey player comes along and I want him in my organization, I walk him over to the team manager and I say, hey team manager, you take care of this guy. So there's the add function in the main, right? I'm not doing the work, I'm just passing it off to the team manager. He can go do whatever he needs to do to keep track of them, that's his business. If somebody comes along and says to me, how many people have you got in your team? I don't really know. Team manager knows. Let me go ask the team manager. When I go and ask the team manager, he's actually hired somebody behind the scenes who keeps track of how many people are on the list, and he asks them. Okay? This is the grand management strategy where where people try not to do any work. Right? The goal is to put a layer of management between you and the work and ask them to do the work instead. They can handle the details, and we just move up a level and don't have to think about all those details anymore. And so everybody at every level is playing this game. Oh, there's somebody who can manage a list for me. Let me make use of them so that I don't have to manage the list myself. Okay? And it's a very good management practice because you isolate people to only doing certain jobs that are at their level, and you have this communication strategy to get the work done. Okay? And if you want a word for it, it's let's be lazy. Right? I don't want to do the work myself. Oh my God, who can I talk to that will do the work for me? Right? And they turn around and they play exactly the same game, and everybody's trying to push the work down to some place where they don't have to do it. Other than to just take what somebody asks, pass it along, wait for an answer, take it and pass it back, which is exactly what's happening here. Somebody's coming along and saying to me, oh, you need to keep track of this player. And I'm going, oh, he'll keep track of it. The list will keep track of it for me. Here, you take it and hold on to it. Okay? And so this is nothing but middle management. It looks really sparse because every time somebody comes along and says do something, you're just passing it on. Anytime somebody comes and asks you a question, you just go, oh, I know who to ask, I'll take whatever they say and I'll send it back. Done. Make use of the facilities that are available. And now we've got two layers, we've got the manager, we've got the team, and we've got a bunch of players that are held underneath. And the other thing that we're doing now is we're restricting things, because now we've got this list of things that we're managing by saying the only thing you can do is ask me to add somebody or say how many people are there. We're gonna flesh this out next week by saying what other things. You know, it makes sense to be able to remove a player from the list. It makes sense to be able to search for somebody who's on the team so that you can pull them out and ask them a question, all of those sorts of things, but we've now added another layer. Okay? But look what happens to the main program, right? The driver just becomes really, really easy. Don't see the list anymore, don't care. I just got a team, I just dump players on the team, done. Okay, and that's a good place to stop for today.